Right, this is Unit 6, Learning Target 5. So the first couple parts is going to be some definitions. So expanded form, we also call that general form, and it's written out without parentheses. Everything's combined. And factored form is written out as the product of two or more expressions. So I'm going to kind of explain this one first to show that one. So factored form would be like when we have it like x plus 2 and then x plus 5 equals y, because it's two factors, and then this is when I would want to FOIL to get my answer. My FOILed answer is going to be that expanded form. So x times x is x squared, x times 5 is 5x, and then 2 times x is 2x, and then 2 times 5 is 10. But my expanded form, I don't write it like this. I actually combine those. So my expanded form would be like x squared plus 7x plus 10. I don't write this. So this right here would be my factored form, and this right here would be my expanded or general form. So the zero product property, if the product of two or more factors equals 0, then at least one of the factors equals 0. So if I have like a and b to equal 0, one of those has to be 0, either a or b, if not both. Alrighty. So we're going to solve each of the equations below for x. So all that means is that there's two factors. So that means one of them is going to equal 0. So all I'm doing is setting each of them as like mini equations equal to 0. So I'm going to take this first one. So I have x minus 9 equals 0. Or I'm going to have 3x plus 4 equal to 0. So then I solve, I'm going to add 9. So I can have x to be 9 or minus 4 minus 4. 3x equals negative 4, divide by 3, divide by 3, x equals negative 4/3. So I'm solving them below for x. So that means my y is 0, so this is kind of like finding my roots. If this was a y and I made y to be 0, my roots are here, 9 and negative 4/3. I'm just setting each part to 0. Here there are three parts, 1, 2, 3. So that first one is 4x is equal to 0. My second one is x plus 6 is equal to 0. And my last one is 4x minus 9 is equal to 0. Here I divide by 4, x can equal 0. I add 6, x can equal 6. And I add 9, 4x equals 9, divide by 4. X can equal 9/4. So this one has 3 roots, so this wouldn't be a quadratic anymore because this would have a factor of like x to the 3rd power. But I just wanted to show you that however many roots there are, you set them equal to 0. That's all we're doing. All right, so let me move this a little bit. So solve each of the equations. I'm actually going to put that over there. Solve each of these equations for y equals 0, but first factor using the zero product property. So all I'm doing is I'm going to switch all of these so that way it says like x squared minus 2x equals 0. I'm going to set all of them equal to 0. 2x squared equals 5x plus 0. X squared plus 10x plus 25 equals 0. Wherever there's a y, I'm making it 0. X squared plus 11x minus 42 equals 0. Okay, so for this one, it's already equal to 0. I can begin. So what it's saying is to factor out an x. So I have an x squared and an x. I can make that as x. I pull out one x. Here, if I pulled out an x, I'm still left with an x. If I pull out an x, I'm still left with a minus 2 equaling 0. And now I have my 1, 2 terms. So x equals 0 and x minus 2 equals 0. So there's my one answer. I don't have to do anything more with that. I add 2. I add 2. So x is going to equal 2. So this one, I want to move this because it would be equal to 0 if I didn't have this plus 5. So I'm going to minus 5x. So then I'm going to get 2x squared minus 5x equals that 0. They both have an x in it, so I'm going to pull out an x. This is leaving me with a 2x, and this is leaving me with a minus 5. So now I have x equal to 0 and 2x minus 5 equal to 0. I should box that one. This one is already done. I don't have to do anything with it. This one I'm going to add 5. I then get 2x equals 5, divide by 2. And then I get x equals 5/2. For this one down here, it's already set. I can't pull out an x because this 25 doesn't have an x. So this is where I'm going to want it, like, this is already a factored thing from my foiling. This is like reverse foiling, if that's what we want to call it. So one way that I like to do this is by making a little box to help me out. And so I want to get this answer. Well, so I know that I'm starting off with x squared. And to get that, I have to do x times x. That's the only way I'm going to get x squared. I want to finish with 25, so my 25 has to be in here. So different ways that I can get 25 is 25 times 1 and 5 times 5. So those are my two possibilities. This could be 21 and 5, or 25 and 1, or 5 and 5. But I want to pick a number so that way when I add up these two boxes, it gives me this 10. So if I look at 5 and 5, right, x times 5 is 5x. 5 times x is 5x. And when I add 5x and 5x, it should give me this 10x, and it does. So now I know that I'm correct. It's going to be x, and then it was a positive 5, so I'm going to put here x plus 5, x plus 5. So then that still equals 0. If I want to, I can say that that's x plus 5 because I'm multiplying by itself squared equals 0. Or I can just say that x plus 5 equals 0. I don't have to write it twice because it's the same thing. Minus 5, minus 5. X is going to equal negative 5. If I did it here, square root both sides. X plus 5 equals 0. And then that brings me back to that same thing over here. Over here, again, I can't pull out an x because this 42 term doesn't have it. So that's where I'm going to want my factors. So I'm going to make that box. Again, I want this to say x squared, so this has to be x and x. This I want to be a negative 42. So I'm just going to look at factors, and I'm not going to count in the 42 right now. So I have 1 times 42, 2 times 21, 3 times 14, and then 6 times 7. Those are all my factors. And so what I like to do, and I think this might be a little easier, and maybe I'm going to split these up by maybe colors. Hold on. And I'm going to look at these separately. And I'm going to look at them as like this one, then this one, and this one, this one. And I want to somehow get to 11. But it has to be a negative. So that means one of these numbers has to be positive, one number has to be negative, because when I multiply them, a positive times a negative gives me negative. I don't care which one is which. So if I make one of these positive, one negative, I want to somehow add to get to 11. So if I did positive 1, so if I look at it like this one, positive 1 plus a negative 42, or negative 1 plus 42, I'm not going to get 11. So this one does not work. 2 and 21, so I can do a positive 2 plus a negative 21, or a negative 2 plus a positive 21. So these, again, are not going to give me 11. If I look at 3 and 14, a positive 3 plus a negative 14, or a negative 3 plus a positive 14. So this is going to give me negative 11, and this is going to give me 11. So now I see that this works. So I want here to be a negative 3 and a 14, because here I'm going to get negative 3x, I'm going to get 14x. 14x minus 3x gives me that 11x. So that gives me that final answer of x minus 3 and x plus 14. So then I'm going to now erase this. So then I'm just going to plug it back in. They both are set equal to 0. X minus 3 equals 0. X can be 3. X plus 14 can be 0. So x can be negative 14. There would be my 2 here. Okay, so again, x squared minus 13x plus 42 equals 0. I can't pull out an x because all of my terms don't have an x. This is where I'm going to do this little box thing again. So then I want x squared here and a positive 42 here. So this is going to again be x times x. My 42, 1 times 42, 2 times 21, 3 times 14, 6 times 7. And now I want a positive, so when I multiply, they should both be positive, or they can both be negative to give me a positive answer here. They're either both positive or both negative. And I want my answer to be a negative 13. So to add, I can't add 2 and get a negative, so it has to be that they're both negative. So right away I know that they're both going to be negative. So in here, it's going to be like x minus and x minus. So then I think, which of these, if I put them both as negative and I add them, is going to give me 13. Well, negative 42 plus a negative 1 is going to give me a negative 43. Negative 21 plus a negative 2 is going to give me a negative 23. Negative 14 plus a negative 3 is going to give me a negative 17. Negative 6 plus a negative 7 is going to give me a negative 13. And negative 6 times negative 7 is 42. So negative 6, negative 7, right? Negative 6x, negative 7x, 6, 7x gives me that 13. Negative 6 times negative 7 gives me positive 42. So I have minus 6 minus 7. So then this is equal to 0. So I have x minus 6 equal to 0. So x can be 6. X minus 7 is equal to 0. So x can be 7. And then this one. I'm going to say 10 plus 0 equals x squared minus 3x. I just want to minus a 10 over. So that way I have 0 equals x squared minus 3x minus 10. I can't factor out an x because this one doesn't have an x. So I'm going to do that same thing where I want to factor. So here's my little box. I want this to be x squared, and the only way I can get that is x times x. I want this to be a negative 10, and my factors of 10 are 1 times 10 and 2 times 5. For it to be a negative, I have to have one number positive and one number negative. I don't care which. But when I add them, I want it to be negative 3. When I add these two, whatever these two give me, I want it to equal negative 3x. So if I did try 1 and 10, making one of them negative, it doesn't matter which one, negative 1x, and then it would have been plus 10x. That gives me a 9x. If I switch it, I have 1x plus a negative 10x, which gives me negative 9x. I don't like it. That's not giving me this. So then if I try negative 2x plus 5x, I get 3x. And then if I try 2x plus a negative 5x, I get negative 3x, which is what I wanted. So that means I want my 2 to be positive and my 5 to be negative, giving me that 2x and that negative 5x, which will give me that 3x. So then I plug in here x plus 2, x minus 5. So then I have, and I'll do this one in red now, x plus 2 equals 0, so x can equal negative 2, because I'm going to end up minusing. And then I have x minus 5 to be 0, so x can then be a positive 5. Positive 5, negative 2. I understand that that might be a little confusing, and we're going to do some practice that in class, so that'll be fine. Don't worry if you're having a little trouble, but there are 3 before class problems. See if you can solve those, kind of doing a little bit of what we were just doing in this.